OpenStax first. I wanted to look at the these questions. All right, so on this one, we want to rank the potentials, right? I think y'all seen this one. What you have to realize is that your charges, when they go through a battery, they gain energy, and then they lose energy when they go through the resistors. And then they gain energy, and then they lose energy. And if you really wanted to do this correctly, like if you really wanted to figure out what is the potential at each point, the way that you could do it is that you could just rewrite it. When I have two batteries that are like this in series, the 24, and I have this 24. Hold on, I'm sorry. Give me just a second. When I have the 24 volt right here and the 5 volt, you can just replace those with a 29 volt battery because they're in series, they're both going in the same direction. We began to see that today with batteries, how they can have sort of different potentials, but in this case I just have two that are strung together, and so I could just rewrite this circuit. You can just rewrite this circuit as a 29 volt with a resistor there and a resistor there, just in order to find out the current that's in that circuit. Because if I have 29 volts and what's like 800 ohms, then I can figure out what is the total current, and then I can go about and I can begin asking what is the potential at different points. And so like right here, just coming right before I go into that battery, I'm going to have 0 volts. And then I'm going to go in, I'm going to gain energy, I'm going to gain 24 volts, joules per coulomb, and then I'm going to lose energy. And what you need to do is figure out what is the potential drop across that resistor. But you need to know the current in order to find that. Okay? There might be a better way to do it, but I think that's probably the most intuitive way to do it, is to actually figure out the current and then calculate the potential drop across each resistor. Yeah.
So you combine the voltage and the resistor by dividing 24 by 300?
No. What I did is right here, when I have the 29 volts, when I have two batteries that are back to back like that, when I have two batteries like this, I have the 5 volt and the 24 volt. This is the same as having a 29 volt battery. Right, when you have two AA batteries, they're sort of back to back like that, and they're equal to 1.5 volts each, but when you put them back to back, then you get 3 volts. So here, the only reason I was doing this, combining those two batteries, is so that I can figure out the current in the circuit. And then once I find out what is the current, then I can begin to ask what is my energy at different points. I know right here it's 0, and then I gain 24 volts, but then I lose some energy. And then I gain some energy, and then I lose some energy. Okay? Does that give y'all a place to go from there?
So you like combine the resistors and multiply, then divide that by the voltage.
Well, if I want to find the current, that's V. If I want to find the current, that's equal to V divided by R. So yeah, I'd want to find the total resistance and then calculate what is the total current.
And you said find the potential difference between each resistor?
Yeah, so as I said, if I imagine my charge right here, it has no energy. It's been through the circuit and it's spent all of its energy. But then it gains energy going across this 24 volt, but then it loses, not all of that energy, but a little bit of it. That's going to be equal to 300 times I, whatever my current is. And then it's going to gain energy, and it's going to lose energy, and it'll go back to 0 here. So you can probably figure out what's the lowest point of energy. What is the lowest point? A, B, C, or D? Be D, right, because my charges have lost all their energy at that point. Let's look at this one. Nobody, well, only one student has asked me about this one, but I think it's kind of difficult. Don't y'all think it's a little bit difficult?
No.
You don't think it's difficult? I thought it was difficult. Yeah, you have to figure out what is the equivalent resistance of this. And so really the question becomes first is how many parallel branches are there? Are there 2, 3, or 4 parallel branches? And I'm going to tell you that there are actually 3 parallel branches in this. There's one at the top, there's this one, there's one right here, and then there's one in the bottom. There are 3 parallel branches. You'll see this? I have one here, and then one right here. This is a parallel branch. And notice how the resistors, they come together. So within that parallel branch, you're going to have 2 smaller parallel branches in series with one another. Okay? Oh, I'm not going to draw it, but I'll describe it to you in words. That I have a parallel branch here, I have a parallel branch here, and then this whole thing down here is another parallel branch. And it has 2 parallel branches in series with one another. Okay? When you have things like this, I can move this whole thing all the way over here. Like this little part right here is kind of unnecessary. But I have 2 parts right here that are in parallel, but they're also in parallel with this and this. So it's like they're separate. And since they come together back here, they're in series with one another. So you have to be careful to draw it correctly. And this one's a little bit tricky. Parallel, parallel, and then this thing is parallel with 2 clumps in series with one another.
So once the parallel branches are combined, they are treated as a series.
Right, down here on the bottom. All right. Y'all try it out. We can chat about it afterwards if you're not seeing it. I can help you. And then there was this one. Suppose you measure the terminal voltage of an alkaline cell to be 1.585, and there's this internal resistance. What are you looking for? What's this? What is this one looking for? William? What's this? What's the question on this one? Like I don't have the question written down here. So
it's looking for 20. It's looking for what current flows.
oh, what is I? Okay. So what this tells us is that, oh, this is a good question. I have my battery. I don't know what E is. Do I?
Yeah, it's 1.585.
No, that's the terminal voltage. So the terminal voltage is what I read over the voltmeter. I have 1.5. Oh, I'm sorry. I don't usually use PowerPoint.
Looks like technology is not on your side today.
I have my voltmeter is reading 1.5. I'll try it this way. Very sorry. My voltmeter is reading 1.585 volts. I'll write on the board, but then people won't see it, but let me just show you here. So I have my battery, and then there's my resistor, and then I have my voltmeter here, and I'm told that my current is flowing in this direction. And I know that I have 1.585 volts here, and I'm told that this resistor is 1 kilo ohm, so that's 1,000 ohms, and this resistor is 0.1 ohms. And I'm just looking for the current, right? How would I find the current in that circuit? No. No, you're overthinking it. Like you're thinking terminal voltage. But just think Ohm's law, right? Because I have my voltage, I have the resistance, then finding the current is, once you realize that, it's trivial. But you have to know what is the terminal voltage in order to get this problem. The terminal voltage is not this voltage. The terminal voltage is what you measure here. Because remember, this is our battery, because it includes that internal resistance. All right?
Do we include the resistance from the voltmeter?
Include the resistance. You're right, yeah. So this is really what you're looking at to find the current. All right? I would say it's tough homework, but there are a few questions that really exercise your knowledge of circuits and the things that we've been going over.
According to the book, it says to add the resistor with the internal resistance.
Yes, but that's not the same problem that we have here. This is something different. Because I'm just looking for the current in the circuit. But don't even think of it as a voltmeter. Just think of it as my battery with 2 resistors. And this was 1,000, and this was 0.1, and I don't know what the voltage is here, but I know that the voltage here is 1.585. And I just want to know what is the current. Okay? This is a good test question. Like I could ask you, what is this voltage? What is this voltage? Any one of those things. And because you know this, then it becomes not that difficult to figure out the voltage here. Give me another minute, okay? I want to get my file over into a different type of thing. So let me just pause this for a second.
What about and
What's that?
what about a question like 18?
It's hard for me to pull them up now. Can we talk about them later?
Yeah.
Okay. Can we do circuits? If I do some of these sort of more complex complex combination circuits. All right. Let's see. Let's do this one. We'll make this 2 ohms. We'll make this 4 ohms. We'll make this 3 ohms, and we'll do a 2 and a 2 ohm here, and then let's make this 12 volts. Did we do one similar to this? We might have done one similar to this, but let's try it. So what I want to do here is I want to figure out what is the voltage and the current on every resistor. And so I'll start either right here on this left parallel branch, because it's purely parallel. There's nothing that's in series within it. Or I can start right here to combine these two. So if I start right here, and I'm going to go ahead and do this part too. I can redraw that circuit. A 2 and 2 in parallel, that's a 1 over a half plus a half is 1, right? And then I have 2 plus 4 is 6. And then this is 3. and then this is 12 volts. And then I'll do this part, which of course is 2 ohms. So I have a 1 and a 2, 1 ohm, 2 ohms, and 12 volts. And let's just do it, the hard way, although we could look at how the voltages are distributed. This is 3 ohms with 12 volts. Now I begin stepping back. And we sort of did this with capacitors too, where we'd start here and then we'd figure out what is the charge on the capacitor. Capacitors in series have the same charge, and so we'd step back to our next previous circuit. And we'll do the similar thing here, where we ask, what is the current? And I know that my current is equal to 4 amps, because I is equal to V over R, or 12 over 3. So that means I have 4 amps here and 4 amps here, because resistors in series have the same voltage. Now, I can say that V is equal to IR, so this resistor has 4 volts, and this resistor has 8 volts. And just double check that. The bigger resistor has the bigger potential, the smaller resistor has the smaller potential, and those two potentials add up to equal to 12, as they should. Almost done. I know I have 4 volts here. Because I had 8 volts on this one, I have 8 volts here and 8 volts there. And then one more step. Oh no, a couple more steps actually. I have 4 volts here, 4 volts here, and then I have 8 volts here. That's just the same as what I had here. That resistor is the same. And now I need to figure out how the voltages are split between these two resistors. And in order to do that, I have to figure out what is the current. So coming up here, my current is V over R, that's 8 over 6, or 4/3 amps. So that means I have 4/3 amps here and 4/3 amps here, because resistors in series have the same current. So V is equal to IR, that is 8/3 volts. Here, V is equal to IR, that is 16/3 volts. And I add those up, and I get 24/3, that's 8 volts, which is good because it should be 8 volts. That's probably going to be one of your free response questions, that you have a combination circuit with several branches within it that are in series or in parallel, and you have to find the voltages. So it's probably going to be your constructive response, along with a capacitor circuit, and then also, we'll see later, a multi-loop circuit, which is similar but different. Okay? Look back. We've done several of these in class, but at the old test, there are a number of them too. Let's see if I can find another one. Oh, that's a multi-loop. These are different. Like we're going to get to these. If we have time, if y'all want, we can look at them. Nope, nope. This is just like my figures file. Oh, let's try this one. Is this one the same? No, this one's different. Yeah, so I make all my figures, and so this is just where I've made my figures. All right, so I have a 4 ohm resistor in series with this big parallel thing. When I go to simplify this, I'm going to start with R3 and R4, because these are purely series. And I look for the thing that is only series or only parallel. And this will be 3 ohms. And then I'll have a 3, 6, and a 2 in parallel. Gosh, what was 3, 6, and 2? Is that 1 ohm? It is 1 ohm? Yeah, so a 3, 6, and 2 in parallel is 1 ohm. And then I have a 1 and a 4 in series. And so my equivalent is going to be 5 ohms. Let's work that out. I think we might have done one like this in class. The numbers seem familiar. But nonetheless, it's good to practice. So I have, this is 3 ohms. And then I have a 3, 6, and 2 in parallel. That's 2, 6, 1, 6, 3, 6. Yeah, so that's 1. And then my circuit looks like this. I have a 4 ohm and a 1 ohm, 10 volts. So that is an equivalent circuit of 5 ohms with 10 volts. Now I begin stepping back. So I have 2 amps going through this circuit. I have 2 amps here and 2 amps here. That means I have 8 volts and 2 volts. V equals IR. 2 times 4 is 8. 2 times 1 is 2. This 4 ohm resistor is the same, so that's 8 volts. And I know that across this whole thing, I have 2 volts of potential. Now, within these branches, which resistors have 2 volts of potential on them? Right. That has 2 volts and that has 2 volts. Because there are no other resistors there to share that 2 volts. But here, it's a little more complicated because they split up that 2 volts. And unfortunately, it's not an easy number for us to do in our head. So we have to find the current. I is equal to V over R. That's 2 volts over 3 ohms. That's 2/3 amps. So I have 2/3 of an amp there and 2/3 of an amp there. And then I can figure out the voltages. This is going to be 2/3 volt. And this one's going to be 2/3 times 2. That's 4/3 volts. 2/3 plus 4/3 is 6/3, which is 2 volts. Which is good. I should have 2 volts across this middle branch, just like I had across these other 2 branches. Again, another good test question. Yeah, let's do that as a test question. Like a circuit like this. It'll be different numbers, of course, but a similar difficulty to this, where you have, what does that one have? 5 resistors, 5 or 6 resistors in parallel and in series. Now, I can do that on a constructed response. Constructed response should be perfect. That should be an easy 8 questions for you to get right. Because I'm going to tell you what they are. I mean, not the numbers, but you'll know what to practice, okay? And you can show your work, so even if you make a mistake, you can still get partial credit. It's a good thing for y'all. All right, let's see if I got some others. Oh, this is a good one, too. Yeah, some of these are, so I don't think this one is. All right. So this one has 8 resistors, but it's not that much more complicated. Okay, let's just see. I don't know if these numbers work out well, but I'm going to start right here. I have 8 ohms. And right here, I have 4 ohms. I just combine those two. And then I'm going to combine this branch. I have an 8 and an 8 in parallel. What does that give me? 1 over 8 plus an 8. That's just 4. Oh, that's a good one, right? So they do good. Man, look at you. You're awesome. So that I know this resistor is 4 ohms. And then I have a 2, 4, and a 4. So I say 1 over 2 plus 1 over 4 plus 1 over 4. That's 2/4 plus 1/4 plus 4/4. That's 1, right? So I have 1 ohm. And then I have another 1 ohm. And then this is all connected to a 12-volt battery. All right, so each of these 3 resistors right here, the 1, and the 4, correspond to R1. The second one is this whole thing in the middle. And then the third 4 ohm, third resistor, the 4 ohm, is that last parallel branch. So now you want to find out what is the current. Well, I have 6 volts here, or excuse me, 6 ohms and 12 volts. That tells me that I have 2 amps of current. So I have 2 amps here 2 amps here, and 2 amps here, because resistors in series have the same current. That means that I have 2 volts, 2 volts, 8 volts. 2 plus 2 plus 8 is equal to 12. Now, most of this is pretty routine to set out all the voltages on these others. I know that this is 2 volts because it's the same as this resistor. This one is 2 volts, and this one is 2 volts because they're in parallel, and parallel resistors have the same voltage as their equivalent. But I have to do a little step here because I have 2 resistors, R3 and R4, sharing that 2 volts. And so R3 and R4 have a voltage of 1 volt each. Y'all follow me on that? I don't have to go through the whole business of finding the current because they're identical resistors. Now this last part, I know that I have 8 volts here, and then I need to figure out what is the voltage on each of these. But these numbers work out pretty easily because I have 8 volts across 8 ohms, so I'm going to have 1 amp of current. So what's the voltage here for R6? If I have 1 amp of current across a 5 ohm resistor, what is that? It's 5 volts and 3 volts. Okay? So those are all the voltages. And then if I ask you for the current, well, I is just V over R. So my currents here will be 2 amps, 1 amp, a half an amp, a half an amp, a half an amp, which, by the way, let's just point out there that if I have 2 amps here, I have 1 amp, I have a half an amp on this branch, and I have a half an amp here. I can check to make sure that I've done that correctly because 2 is equal to 1 plus a half plus a half. That's my junction rule. And then over here on this last branch, I know I'm going to have 1 amp and 1 amp, which again is the same as 2. When I have identical resistors in parallel, they'll have the same current. They have the same voltage anyway, and if they're the same resistors, they'll have the same current. So you can just split up the current identically. Okay? That one, I don't know if I'd give you that many resistors, but the level of difficulty is similar to what I would expect for the exam. Yeah.
I hate to refer people on myself again, but I just don't get how voltage is divided amongst the resistors.
Okay. Okay. Well, when I have identical capacitors, they have the same voltage. You got that?
Yeah, I just don't know where division comes in from 12 to 2 and 1.
So we split up our voltages in our simpler circuits. So right here I create my simplest circuit of all. And I figure out that, oh, I have a 12 volt and a 6 ohm resistor, so that circuit has 2 amps of current. And then I step back and I say, okay, I have 2 amps here, 2 amps here, and 2 amps here. Because resistors in series, they have the same current. Now, if I have 2 amps over a 1 ohm resistor, since V is equal to IR, that tells me I have 2 volts of potential. 2 volts of potential here, and here, I, which is 2 amps times 4 ohms, gives me 8 volts. So I know that in class, like, sometimes we do this thing where I just say, well, let's just look at it and figure out what the voltages are. And if that confuses you, then by all means, don't do that. But you go through each of these steps where you find out what is the total current in the circuit, and then once you find that current, then you find what is the voltage on the individual resistors. But I think that as you get better, that you'll begin to see how these voltages are split up. But for now, I think just do it this long way, the harder way. No, it's not harder, it's just longer. It takes more time. But you should have time on the test. Okay? And again, practice really helps. Can we try another? Is that okay? Is this the same as we did before? 4, 6, and 1? No, this one's different. But what is a 4, 6, and 1? Is that an easy number to do? Can you do that one in your head? Are you like a savant with numbers? Let's just try it. I'll try it. So I want to find my equivalent. It's the 6 ohms. And then I do 1 over 4 plus 1 over 6 plus 1 over 1. What's my common denominator here? 12. Oh yeah, it is a good one. Well, I didn't know I had all these combinations. This is good. So that's 12 over 12. Oh no, this isn't. Is this right? So it's 12 over 17. Oh goodness, I don't want to do this. This is too complicated. Yeah, can we just not do this one? It's just the math. The numbers are going to get too complicated. We've done one very similar to this. Oh, let's do this one. This one's a little bit different. All right. So I have, first thing you want to do is R3 and R4. Those are 3 ohms, right? 1 plus 2 is 3 ohms. I'm going to redraw each step here. So I have 12 volts. There's my 3 ohm, 3, 3, and 3. It's 12 volts. Okay? When I have 3 resistors, 3 in parallel, that's what? 1, right? 1 over a third plus a third plus a third. That's equal to 1. So my circuit is 3 ohms, 1 ohm, 12 volts. And then I draw my final simplest circuit. Looks like this. I have 4 ohms, 12 volts. Now, I start stepping back. I know here that my current is 3 amps. I know that because I is equal to V over R. That's 12 over 4, which is equal to 3 amps. Now, because these are in series, I know they both have the same current, which is 3 amps. And I can figure out what is the voltage, because V is equal to IR. The voltage is 9 volts and 3 volts. 9 plus 3 equals 12. Then I can step back here and say, well, this is 9 volts. That's the same as what I had down here. And because these 3 ohm resistors are in parallel, I know they each have 3 volts of current across them. By the way, I also know that they each have 1 amp of current. And I know that because they all have 3 volts and they're all 3 ohms. 3 over 3 is 1. And I can go ahead and tell you what is the total current in this circuit because I know that all my current comes into this parallel branch and splits into 3 parts. So what is my total current? What is the current that is coming right here? It's not 1 amp. Instead, it is 3 amps is right. Because whatever current comes in here, it splits into 3 equal parts. Or the sum of those currents have to be equal to what's coming in. And by the way, we could have seen that because here I have 9 volts across 3 ohms. That's 3 amps. I is equal to V over R. Okay, so I know that I have 1 amp of current here. V is equal to IR. So I have 1 volt and 2 volts. 1 times 1, 1 times 2. And then I can fill in the rest of these. This is 9 volts, 3 volts, 3 volts. And that's it. And then if you want to know the current in any one of these, I think we labeled them all. But if you wanted to know that, I have 2 quantities on each of them. And so I is equal to V over R for all those. Okay? Another? Or y'all want to call it a day? It's up to y'all, really.
I'm still processing all this, just trying to take down notes and keep up.
I understand. You want to do another, or y'all want to call it a day?
I know earlier you had said you would want us to calculate the voltage at like a specific point.
Yeah, let's do one like that. Like I'll do one like this. Is that what you want? Yeah, so let's say that I have a circuit and I don't know what the voltage is. But let's say that I want to know what the voltage is. And I tell you that there are some resistors out here that are 1 ohm, 2 ohms, and 3 ohms. And then I tell you one of the voltages. Let's say that the voltage over here is 12 volts. And I want to know what is the voltage on the battery. Now, you might be able to look at this and say, I know if this is 12 volts, this voltage has to be what on the 1 ohm resistor? 1/3 of that, right? So I can approach the problem that way and say that this voltage over here has to be 4 volts. I'm going to show you a different way that might be easier. And then the voltage over here has to be twice that, or 8 volts, because it's twice the resistance. And that would mean that this voltage would be 4 plus 8 plus 12, or 24 volts. The easier way, though, maybe, I don't know if it's easier, I think that way is pretty easy, but maybe the sort of the more consistent way is to say, what is my current here? And my current here is V over R, or 12 over 3. So I have 4 amps here. That means I have 4 amps here and 4 amps here. Then that tells me that I have 4 volts here and 8 volts here. This is the same problem as this one. It's exactly the same. And then if I want to know the voltage here, it's 4 plus 8 plus 12, which is going to be 24 volts. You look back at some of the old tests, there are problems like that. There'll be a fourth constructed response. It might be one like that, but it might also, we'll get into this next week, it might also be one with multiple batteries. Not a multi-loop circuit, a single loop, but with multiple batteries.
And whenever that's the case, you can just treat as the batteries in series.
Yeah, we're going to get to this, but if I have 2 batteries that are like this, like say I have 12 volts and 3 volts, I can replace it with one that's 15 volts. But if I have 2 batteries that are like this, right? They tell you to make sure you put your batteries in the right way. There's a reason for that, because this would be like 12 volts and minus 3 volts. We began getting into that today with the little rules right at the very end of class. And so this would have a net voltage of 9 volts, 12 minus 3. Don't worry about that, though. We'll get into that next week. You'll have lots of fun with Kirchhoff's rules, the loop rule. Okay? I appreciate y'all coming out. I know it's Friday before the break, and even though it's not a holiday yet, it's not started the holiday, it just sort of feels like it is. I'm going to stop this, but I'll